Hey, algebra students, in this lesson, we are going to be talking about how to solve rational equations. What is a rational equation? Well, when you hear the word rational, you should really think fractional, okay? Because it's an equation that includes at least one rational expression, meaning it includes at least one fraction that has a variable in the denominator. Notice as you look at the problems we're going to be working in just a bit, all of them have fractions with variables in the denominator. That makes these rational expressions. And because they have an equal sign, it makes it a rational equation. Now, because there's just one variable in each one, there's x, right? X is our only variable. There's no y. Because there's just one variable, we can solve these equations for values of x. And we're going to learn how to do that. One of the problems, though, because we're dealing with expressions that have variables in the denominator, is we're going to need to check all of our solutions to make sure that they don't make any of the denominators zero. If we have any answers that make denominators zero, those can't actually be solutions to the equation. We call those extraneous solutions. They look like solutions, they solved like solutions, but when we actually plug them in, they can't be solutions because they change one of the denominators to zero, and that is not allowed. All right, we're going to solve some equations, and I'm just going to tell you the first thing we need to look for is, do we just have one fraction on either side of the equal sign? Look at letters A and B. Notice in letters A and B, one fraction equals one fraction. One fraction equals one fraction. When we have a fraction on either side of the equal sign, these are going to be really easy. But look at letter C. Notice in letter C, I have two fractions on one side of the equal sign. That's going to make things a little bit harder. I'm also going to point out that on the right side in letter C, we have just a number. That's okay. A single number is like a fraction because 5 would be very similar to just writing 5 over 1. So because we can express it as a single fraction, just a constant number or a number that doesn't have a fraction bar is fine. But we are going to have to deal with these expressions being added together, like in letter C. In letter D, we have ones being subtracted from each other. We're going to have to learn how to deal with that. Okay, but let's do letter A first. When we have just a fraction on either side of the equal sign, this is going to be really easy. All we need to do is cross multiply to solve. Okay, so we're going to cross and multiply 7 times x and then 6 times x plus 1. You do have to be careful to use good rules of algebra. Okay, so I'm going to do 6 times x minus 1. Notice I'm not multiplying the 6 just times the x. It has to be distributed across the x minus 1 equals 7 times x. So if I were to simplify this further, I'm going to distribute the 6. 6x minus 6 equals 7x. Or, let's see, I'm going to subtract, best thing for me to do is subtract 6x from both sides of this. That gives me negative 6 equals x. All right, let me just plug in negative 6 into my original equation. 6 over negative 6 is negative 1. Notice that didn't divide by 0, so that's okay. 7 over negative 6 minus 1, well, it's negative 7 on the bottom of the fraction. 7 over negative 7 is negative 1. Negative 6 is an actual solution to this equation. Let's move on to letter B. In letter B, we have the same sort of thing going on. I'm going to need to cross multiply. In this case, I'm going to have 2 times 6 is 12 equals x times x plus 4. Now, I see this x times x plus 4. That's going to be an interesting problem to solve because that's going to give me an x squared. So I'm going to have a quadratic here. It's going to be 12 equals x squared plus 4x when I distribute that x. Hey, do we have a way of solving a quadratic equation? Well, we learned that in the last lesson. If I just subtract 12 from both sides, I get 0 equals x squared plus 4x minus 12. And then I can factor this expression and make this is going to be set equal to 0. So what am I left with here? This is going to be 0 equals, let's see, what are the factors of negative 12 that equal positive 4. Well, negative 6 and 2 would make negative 4. Positive 6 and negative 2 would make multiply to make negative 12. That would be 4. So it's just going to be, when I factor this out, x minus 2, x plus 6. Now, what are my solutions? Remember, I have to use the zero property of multiplication to make this set of parentheses here, what's in there equals 0, and what's in this set of parentheses equals 0 separately. So in this case, x equals 2 or negative 6. Now let's go ahead and plug in 2 and negative 6 and see what happens. If I plug in 2, I get 2 divided by 2 plus 4 is 6. 2 divided by 6 is 1/3 equals 2 divided by 6 or 1/3. 2 works as a solution. Let's try negative 6. Negative 6 plus 4 is negative 2. 2 divided by negative 2 is negative 1. Negative 6 divided by 6 is negative 1. I get negative 1 equals negative 1. Both of these are valid solutions. Neither of them made a fraction with 0 on the bottom. All right, moving on to letter C. In letter C, I've got problems because now I have to add two fractions before I divide. But this isn't really all that hard. So it's going to be 12 plus 16 equals 5. And then I need to turn these into fractions and put my fractions on the bottom. So it's not just 12, it's 12 over 2x and 16 over 4x. Anytime I have fractions being added or subtracted, the only way for me to deal with those is to get a common denominator, then combine them into a single fraction. Well, I notice that this is 4x and this is 2x. It's really easy for me to turn 2x into 4x. I just need to multiply by 2. So I'm going to put a 2 out in front of this one. And that means that I have to multiply the top by 2 as well. So let me just do that correctly. So I'm going to multiply by 2 over 2. Remember, that just means I'm multiplying that fraction by a fancy version of 1. It's going to give me a number, though, that's over 4x. So 2 times 2 on the bottom is going to be 4x. Okay. And then 2 times 12 on the top is going to be 24. This is my new expression. And now I can add these, 24 plus 16. So I'm just going to do this on the next line down. 24 plus 16 is 40. And then let's see, this is going to be 40 equals 5 on the right-hand side. On this side, I need to make sure I divide my 40 by 4x. Okay, so one thing you might notice right away is I can actually simplify this 40 over 4x. That won't change anything because I still have a fraction equal to a number that can be represented as a fraction. By the way, let's just represent that number as a fraction right away, 5 over 1. I'm just going to go ahead and do my cross multiplication here, though. That's going to give me 40 equals 20x. And then I can divide both sides by 20x equals 2. So if I go back in and plug in 2 for letter C, 2 times 2 is 4, 12 divided by 4 is 3, 3 plus, 4 times 2 is 8, 60 divided by 8 is 2, 3 plus 2 equals 5. That works. 2 is an actual solution. Hey, let's just make sure we've gotten all of these questions correct so far. There we go. All right, and it's on to letter D. Letter D is a really hard one. So we're going to have to really focus on making sure we set this up right. Across the top, I have 4 minus 2 equals 1. But in the bottom, I have all sorts of different denominators. So the denominator for the term that has a 4 is x minus 2. Okay. The denominator for the 2 is just x. That's going to be a bit of a problem. And then the denominator for the 1 on the other side is 3x. And what I need to do is get a common denominator on the left here so that I can actually add or actually subtract these two fractions. Right now, I have a fraction minus a fraction. I can't cross multiply because I have this minus on this side. What I need is a fraction on each side of the equal sign so I can cross multiply. The only way to do that is going to be to multiply this first fraction by whatever factor it's missing between these two. And notice that I have a factor of x minus 2 on the bottom of this fraction, a factor of x. There's no way for me to get the same factor on the bottom except to multiply those together. So I'm going to multiply the first fraction by x over x. That gives me 4x over x times x minus 2. I need to multiply the second fraction by x minus 2 over x minus 2. Okay, now I can add, or in this case, subtract the fractions on the top. So I'm going to start this on a new line. And on the top, I'm going to have 4x minus. What I'm going to do is I'm actually just going to distribute this right away. 2x, it's minus 2 times x minus 2. So it's going to be minus 2x. And then this is minus 2 times minus 2. So it's going to be plus 4. Okay, that is going to simplify things a little bit later on that I just distributed that right away. That whole thing on the left side is going to be divided by x times x minus 2. Now, there's no way I could have canceled anything between the numerator and denominator here because x needed to be in every term for me to cancel, or x minus 2 in every term for me to cancel, and it just didn't work out that way. Okay, this whole thing is going to equal still, nothing on the right side has changed, 1 over 3x. So let me just get our fraction bar in here, 1 over 3x. All right, now I can actually cross multiply at this point, but I think before I cross multiply, let me just simplify this fraction as much as possible. 4 minus 2x, 4x minus 2x is just 2x. So I'm going to put 2x on top over here. And is there anything else I can simplify? I would really have liked to be able to cancel out this x minus 2. But even if I factor out a 2 here, I'm going to have x plus 2 on the top, and that won't cancel down below. There's nothing else that can be canceled. I just have to cross multiply. So let's go ahead and do our cross multiplication right over here. I'm going to have 1 times x minus 2. So that's going to be, and here, let me just write this out there we go. So it's going to be x times x minus 2 equals 3x times 2x plus 4. Okay, now let's just get this. There's nothing that can be simplified here. I guess I could divide both sides by x. That would sure make things easier because I have an x on both sides of my equation. So if I divide this side by x and this side by x, it gets rid of that extra x. Actually, that's going to make things real simple. So now I have x minus 2 equals, I'm going to distribute the 3, 6x plus 12. Okay, now I'm going to subtract x from both sides. When I do that, I get negative 2 equals 5x plus 12. I'm going to subtract 12 from both sides. That gives me negative 14 equals 5x. And now I'm going to divide both sides by x. X equals negative 14 over 5. Now that seems like an odd answer. Let me just make sure I got that right. Negative 14 over 5. I'm going to be fairly certain that if I plug in negative 14 over 5 for any of these x's on the bottom, it's not going to make anything 0. So for letter D, this is the correct answer.